presentations. We're really glad to be here and share a little bit about our Insights Platform for Analytics, IPA. So my name is Abdul. I'm a business-oriented software engineer in the data products team at DNB. So I work with the business use cases and how they can utilize our data platform, IPA, to create business value. And together I will present it with my colleague, Atle.
My name is Atle Esperum, and I'm the tech lead for the analytics tech team in DNB. My team are responsible for building and delivering some of the core components of the DNB's Insights Platform for Analytics.
Thanks a lot. Just one information for the participants. In case you don't see the speakers, please just click the view button on the top so that you can get the option or unpin those whom you pinned before so that you can see the presentation alongside with the video of the speakers. Thanks.
Yes, just a short introduction to DNB. DNB is Norway's largest financial service group and one of Nordic's largest in terms of market capitalization. DNB offers a full range of financial services like loans, savings, advisory services, insurance, and pension products. Some key numbers are 2.1 million retail customers, 243,000 corporate clients, 1.5 million active internet bank users, and 1.3 million pension and insurance customers.
Yeah, so that was a little bit about DNB in general. So in this talk, we'll try to introduce our platform to you, our data analytics platform, IPA. So whenever you hear that acronym, it just think data and analytic platform. And we will try to show you the range of the business cases we have, and especially how data virtualization plays a role in this. Finally, we'll try to end it with pointing to what kind of value is generated and improvement areas we have.
DNB Insights and Platform for Analytics. The goal of this platform is to make it easy for internal data scientists to explore and work with data available in DNB. We want to enable all the data scientists in DNB's different business units to be able to create and deploy production-ready ML models, pipelines by themselves, with just a tiny help from Abdul and his colleagues. The platform are running in AWS and takes advantage of many of AWS services and the scalability of the cloud. The platform consisting of several components and services, like Data Lake, that we have built around AWS S3, AWS Glue, and it supports a high level of self-service by the users. We provide network databases like Neo4j for the moment, but we're also looking into other options like AWS Neptune. We have provide data liberation through Denodo. DNB has a lot of data spread around in different systems and silos. Using Denodo, we have created one place for data scientists to find and explore data. This always gives the data scientist one way to access data, both when exploring and playing with data, and when they create production-ready pipelines. Data Science Laboratory. We provide RStudio, SageMaker, S3 buckets that the data scientists can provision themselves and use to explore data and create ML models. Data Science Pipelines and APIs. That is a platform to create and host ML pipelines, both a test version and a production version, and prediction APIs that they can use from other applications. This guides the data scientists to follow the best practice and give them handrails to help them to fall into the pit of success when developing pipelines. We currently support R and Python in the pipelines. We also have a product called Visualization Service. We provide Shiny Proxy as a service, making it easy for the scientists to create visualization web apps in R or Dash. We also have data orchestration that we provide the product StreamSets. We offer StreamSets to make it easy for the users to move around data around and create no-code data pipelines. Currently, we have about 20 engineers working on enhancing the platform and the services we offer on it. Currently, we have 248 data scientists onboarded to the data science lab, and they can access more than 9,000 data views and more than 40 different data sources through Denodo. We also have around 40 machine learning pipelines running on the platform today.
Yeah, so as you can see, we have a large platform with many users onboarded, and we'd like to turn the focus towards business. I mean, DNB is a large organization. We consist of a vast array of business units, and what we've done is that we try to onboard most of the business units to our platform. I mean, this includes units such as people who work with detection of anti-money laundering, corporate banking, investment banking, risk advisory, and of course, wealth management data, of which Morten Bunes Gustavsen, who presented for DNB yesterday in this conference, is head of. So, okay, we have onboarded a lot of business units, and then the question is like, what kind of business use cases do we help or offer? So we have a wide range of business uses, ranging from the traditional BI reporting to, let's say, state-of-the-art ML models using Python or R. And these business uses are often exposed in form of, for example, batch processing or real-time predictions through APIs. Okay, so we have a lot of business units, a lot of business use cases, and then the question is like, where is the data? And as Atle mentioned, we have a lot of data sources, and we have a wide array of them. And one main of them is an internal cloud-based source with a data lake in AWS. And that is handled by our team, IPA team. We handle 5 to 13 million transactions per day and have a total of more than 7 billion transactions stored. In addition, a lot of our data sources are located on on-prem data warehouses, such as Teradata, Oracle, SQL Server, and so on. So we also use external third-party APIs from, let's say, Google in different business use cases. Okay, so we have a lot of data coming from a lot of places, and at one point in DNB, surveys showed that our data scientists were using up to 80% of their time in connecting to different data sources and integration of data instead of creating models. I mean, they would rather probably create these machine learning and statistical and mathematical models to create business value. So what we did at DNB was that we created a set of criteria and used those criteria to find the best solution for giving access to data. And using some of these criteria, we ended up upon data virtualization using Denodo on the IPA platform. So let's talk a little bit about data virtualization. Using data virtualization, we offer our users a single point of access to access data. So using Denodo, we can utilize data virtualization as like a logical layer on top of all data sources. So all our data sources, data scientists can query and explore data using, for example, Denodo Data Catalog web app, or they can connect to the data using their preferred programming language, such as R or Python. In addition, one of the key features here in data virtualization is that we have the ability to add new data sources. I mean, the data scientists can add new data sources to Denodo due to the many database adapters and drivers Denodo offers. Today, this process is not seamless in our organization because we have to make networking issues like, for example, VPC endpoints or ring openings of firewalls because we're a large organization focusing on security. However, the features are there, and when we have added a data source, data scientists can import and add new views from the underlying data source they need. Another feature that we thought of, which we really like about data virtualization, is the real-time delivery. I mean, since data virtualization connects to the underlying source, we can offer our data scientists the ability to access data in real time without any hassle of data management. And this means that data is often abstracted from the data source for their part. So the idea is that queries also can be optimized using pushdowns. I mean, what Denodo does is it pushes the processing power down as close to the sources to leverage the compute power of the underlying sources. Okay. Another feature we sometimes use is caching. Denodo offers a cache model to store local copy of retrieved data to reduce impact of repeated queries and speed up data delivery. We use this model in certain cases when the underlying database is supported by the so-called cache engine of Denodo. Finally, in the last panel, there was a very nice discussion about different users and different expectations. And of course, we also have a wide area of users. Some of our users are excellent users of SQL, and they would often sometimes prefer to do feature engineering and pre-processing by creating views on top of views. So this is one thing that also Denodo offers those kind of users. They can create views on top of views. Of course, our users who use, let's say, Python and R, they use the standard libraries to do this feature engineering when they need. Okay, let us show you one example of this data virtualization in practice. I think you're muted, Atle.
Sorry. GDPR-Reporting is an excellent use case for showing how with data visualization could really shine. Because this is not a machine learning pipeline, but it's really shining since this is gathering data from a lot of different sources. And we can use Denodo to do the heavy lifting of actually collecting the data from different sources and merge them together to one. So instead of having to write a lot of custom code in the pipeline to gather data from all the different systems, the developer can just go into Denodo, add a simple view, add it, merge it into the existing view that it's using by the report, and voila, the new data is available in the report without having to have a lot of complex code in the pipeline. Abdul?
Yeah, so what Atle shows is an example of the typical traditional BI reporting. Great thing there was, of course, a feature engineering being done on Denodo. But we also offer the typical, how can you say, machine learning use cases, such a template like this. Like, for example, we can have multiple data sources coming into the platform, ingested through Denodo, and then Denodo creates one-to-one replicas of the views of the underlying data sources. Then, for example, the data scientists can use, let's say, Jupyter Lab in Amazon Web Services SageMaker to develop model artifacts, which are stored in Amazon S3. And after that, they can train their model and serve their predictions using an API, which can be consumed to their liking. And all of this is done with CI/CD pipelines. So there is, how can you say, continuous integration and continuous development, and no time lost. So yesterday, when Morten gave this example of insurance fraud, he was talking about such an example. Okay, so we gave you a little bit of examples, showed you a little bit about data virtualization, but I mean, the big questions are, have we created any value? Is it worth it? What have we done? Can something be better? So one of the things I'd like to point out is that with a single point of access to data, we reduce time for our data scientists to search for the appropriate data sets within the vast data ecosystem in DNB. I mean, this is, in one case, given increased agility in initiatives and also generated business values. So one of the other things I think is really nice is that using data virtualization with, let's say, Denodo has also democratized data assets. So it's easier for our users to explore and harvest benefits of our data sets. Okay, so in addition to this reduced time and democratization, we also have seen an increase in data-driven initiatives. And of course, this is like based on the whole platform itself. Of course, there is some kind of correlation. There's not necessarily a causation between the increase in data-driven initiatives and data virtualization. But we've seen that this is also fueled by the engineers in the IPA team, specializing in creating a whole platform that enables and empowers data scientists to spend time building models. And one of the key features has been making a great culture change. So at one point, we hit some kind of critical mass where we see that our users, our satisfied users who create end-to-end products that have business value generated, they're showcasing this on internal platforms such as Workplace and Slack. And in this turn, making other business units see the opportunity and see, okay, it took you so far, so long time to do this. Maybe we'll jump on the wagon. Maybe we'll see if we can do something about it. Finally, another thing that data virtualization, back to that, also offers is a logical layer on top of the data sources. So the idea is that you can also manage access rights through Denodo. You can use like pass-through authentication or pushing the authentication to the data source, or you can create roles or groups within Denodo to manage the user access. Right now, we're working on linking these groups and roles into AD groups in Azure to be able to authenticate easier. Okay, so these are some of the, I think, the benefits or value generated of this platform and maybe of data virtualization. So maybe Atle can share some improvement areas.
Yep, we are very happy with the solution we have today, but as everybody else, we want to improve. We want to take new steps. So when it comes to self-service for adding data sources and views, it's quite easy today, but we want to reduce the time it takes from the data scientist requesting access to data that we don't have in the Denodo for a moment to it's available and ready to be used. We want to make that so short as possible. So the best thing would be if the data scientist could work together with the owner of data and add it to the Denodo directly without the platform team having to be involved at all. It saves time for us and it can get data scientists much faster to the goal. Awareness of our users about the data virtualization. We have had Denodo in our organization for more than 2 years now, and we have many users of it. But we want even more data scientists to join us in the DNB, and we want also others that are not directly data scientists but like love data to use it and harvest the benefits from it. We also need to inform better about what data visualization can do for the data scientist. Many are just using it to read and write data and write complex code to achieve something that can be done much easier in the Denodo without having to maintain a lot of code. Add platform tooling to widen the range of the Denodo functionality. We don't provide today, we don't support all the different functionalities that the Denodo supports. We're mainly using providing JDBC, ODBC today, but we also want to extend this to also cover the REST APIs and the GraphQL capabilities that the Denodo have. And then we have as always, performance. We are struggling with some of our data sources being slow. Caching in the Denodo can help some of the use cases, but not for all. We're also working on educating the data scientists about the best practice and to give them realistic expectations.
Yeah, thank you, Atle. So I see we reached almost 20 minutes. So maybe we'll invite Q&A and see if anyone has some questions.
Thanks a lot for keeping the time. Yes, time for questions, please. Vahid from Electrolux already mentioned that. Thank you for sharing the end-to-end pipeline. I had asked this question yesterday, so I hope, Vahid, you got the reply, yeah? Others, please type your questions here or raise hand that we can give you microphone. Waiting for some challenging question. We have the question from Shafiq from Grandfos. What is additional maintenance or code cost for Denodo?
Yeah, maybe you can take it.
Denodo, you probably need to talk to the Denodo salespeople. But of course, like every other product you have to run, it costs in maintenance. You need to have the competence internally in your company to actually do it. So you need to pay for the competence. You also need to pay for the servers, etc. but we like AWS, so we run everything in AWS Cloud. So we can scale automatically based on load to decrease the cost. Abdul, you want to say something?
No, I think you covered it quite well. So
okay, just Tonia's comment and see if it is a question. Tonia, who is going to present after you. Very nice explanation. What are your thoughts on advancing the CI, the CD with MLOP's monitoring? Are you also looking to SageMaker for that?
that's a really, really great question. I mean, one of the things we are lacking today is the MLOps part. I mean, we know that there's model drift, data drift. There are a lot of issues we're not addressing. And we'd like to do more on that. And that is, in fact, one of the things we're looking at. And we don't know if, let's say, SageMaker is the best alternative, or maybe we have to use some other tool like, let's say, MLflow. But it's absolutely something we have to do. And what we've seen so far is that we have a couple of or a lot of ML models in production, but we haven't reached that maturity yet where we have to understand how to define what we want to do with MLOps. I mean, is it monitoring? Is it logging? How and who is going to do this? So it's absolutely something we're looking at. And I think that's one of our next steps, the IPA platform.
Okay, thanks a lot for the explanations, guys. Now you can just switch off camera and mic. I give